Hello and welcome to this episode of Math with Martinez. We are still in this unit in Algebra 2, all about expressions, factoring, and equations with rational exponents. And our learning goal, what we want to be able to do by the end of this video, is to determine the linear and quadratic factors of a polynomial expression by factoring the sum and difference of two cubes and factoring by grouping. So let's go ahead and begin by factoring polynomials when we have four terms. In order to factor a polynomial, what it means is to rewrite the polynomial so that it is expressed as a product of two or more polynomials. And remember, the product is just the result of multiplying two or more things together. It's the result of multiplication. So we're going to try and take all these terms which are being added and subtracted and rewrite it so that what we have are things multiplying together. Those things that are multiplying together are called the factors. So we'll have a factor and a factor multiplying together. So when you have several terms like this, when you have four terms like we have here, factoring by grouping is often a wonderful approach. We'll begin, like we see here on the right side, by grouping the first two and the last two terms together. That is to write this polynomial as 2x squared plus 8x. I've grouped the first. Add to that the 3x plus 12. I have grouped my first two and my last two terms. Then what we're going to want to do is from each of those groups, we're going to factor out our GCF. So now that we've done this first step of grouping the first two and last two terms, we're going to want to move on and factor out the GCF from each group. Okay, well, what is that GCF? The GCF means the greatest common factor. So what is the greatest common factor from our first group? What's the biggest number that we could divide out from each of those two terms? What's the biggest number that we could divide out of 2x squared and the biggest number that we can divide out of 8x? The biggest that they have in common would be 2. Now, what about the greatest number of x's that we could divide out from each? This one, the first term has x squared, the second has just a singular x. So the most we could divide out is just 1. And what would be left? Well, it's essentially undoing multiplication. So you're asking yourself, 2x times what would give me 2x squared? That would just be x. And 2x times what would give me this 8x? That would be a positive 4. And we want to now do the same thing with the second grouping. So what can divide into 3x and 12? What's the greatest common factor there? Well, the greatest number would be a 3. And then could we divide out a variable from both? No, we can't, because this second term doesn't have a variable. So our greatest common factor from that group is 3. And now we ask ourselves, 3 times what would give me 3x? It would just be x. And 3 times what would give me 12? That's going to be a positive 4. So we have now gone ahead and factored the GCF out from each of those groups. Then our final step is going to be to factor out the common linear binomial. What is that common linear binomial? Well, let me show you here. What is the linear binomial that they both have in common? They both have this in common. That common linear binomial is what you should have inside parentheses. If they don't match up, then you probably made a mistake. So if we divide that out, if we pulled that out from this first set and from the second set, what is left? What was in front of each of those? Well, in front of the first one, we had a 2x. So if we pull that out, all that would be left is the 2x. And from our second group, what are we pulling? If we pull out the, like I said here, if we divide this out, what is left is just the 3. And so there we have it, ladies and gentlemen. This is undoing our distribution. We have 2x plus 3 multiplying with x plus 4. We have factored out that common linear binomial. And now what we have are 2 factors, right? These are both my factors. That if I were to multiply them together, would go back, it would take me back to this that we began with, that polynomial that we began with. If I went ahead and did the double distribution, it would be this polynomial. So there you have it. That is factoring by grouping. Let's try another one like it. Let's go ahead and begin, like it says, by grouping the first 2 and the last 2 terms here. And this is a negative 8x plus 4. Okay. Then we want to factor out the GCF from each of the groups. What is the GCF from that first group? The greatest that we can factor out, they don't both have a number that we could factor out. It would really just be a 1. But the greatest, when it comes to the variables, would be to factor out a x squared. We could factor that out, and what would remain is a 2x minus a 1. Don't forget that minus 1, because that's what would take you back to the negative x squared. What about from our second group? From that second group, what I could divide out is a negative 4. And I'm doing that strategically because if I take my negative 4 times, what would it need to be? It would need to be a 2x. My negative 4 would need to multiply with a negative 1 to give me what I had above, a positive 4. I did that strategically because if I would have only factored out a positive 4, this guy and this guy would not have matched, and I would have been stuck and unable to complete this next portion, which is what we want to do. We want to factor out that common linear binomial. And I do see that I have a common linear binomial that I can factor out. And what remains is x squared minus 4. Those are the GCFs, right? Do you see that? Those are the GCFs from the 2 groupings. Now, we are not quite done here because you'll notice that what we have is not linear in this second case. Do you see here how this guy right here is not linear? He is quadratic. Above, we had linear factors. But because this is quadratic, I want to check that one. I want to check that because you know what? That is a special quadratic binomial. If you look at your factoring reference page, that factoring guide, you'll be aware that that is actually a difference of squares. So we want to factor that difference of squares. Keep this part the same, but then the difference of squares, when we factor that down, we ask ourselves, what times what gives me x squared? X and x gives me x squared. These are conjugates, so one will be plus, one will be minus. And what times what gives me 4? Same number. What times itself gives me 4? It is 2. So there we have it. We now have factored that difference of squares, and every single one of these are linear factors. These are all the linear factors. And they are this has now been completely factored, and we are good to go. That is factoring polynomials when what you are starting with are 4 terms. Stay tuned. We're going to look at what to do when you only have 2 terms next.